Hello, welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, what is the difference between HashSet and TreeSet in Java? Let me answer this question with practical demonstration. Both HashSet and TreeSet belongs to collections framework in Java. Under collections framework, there are a lot of predefined classes and interfaces, whereas HashSet and TreeSet are few of them. So as the names are similar, right? HashSet and TreeSet, the names are similar. And also there are some common things between the HashSet and TreeSet. Before I explain the differences between HashSet and TreeSet, we have to understand why this question came. What are the commonalities between this HashSet and TreeSet? I need to explain first. The common things between this HashSet and TreeSet are their parent interface is set interface. HashSet is a child class of set interface. TreeSet is also a child class of the same set interface. They don't allow the duplicate elements. If you try to store duplicate elements into this HashSet or TreeSet, okay, the duplicate elements will be ignored and only one out of the duplicate elements will be considered. No duplicate elements will be allowed, only unique elements. Then they both belong to the collections framework and they also inherit the same type of classes from the collections framework, which is a parent of the collection interface, which is a parent of the set interface. They inherit these methods like add method, remove method, clear, size, is, empty, contains method. Both have the same set of methods which are inherited from its grandparent interface, which is a parent of the set interface. And it's not thread safe, guys. Okay, that means not synchronized. Not thread safe means if you use this HashSet or TreeSet in a multi-threaded environment, there is a possibility of getting some exceptions because one thread may interrupt another thread. Okay, so it's not synchronized. It may be fast, but ultimately the thread safety is not there. In a multi-threaded environment, we should not be using them. In a single-threaded environment, we can use HashSet or TreeSet because it will be faster, but not synchronized. Okay. Fine. These are the common things between the HashSet and TreeSet. Now let's understand the differences between HashSet and TreeSet. Coming to the HashSet, what are the differences we have? HashSet, TreeSet. The name set sounds same, but here HashSet is there, here TreeSet is there. Here, coming to the HashSet, the elements are not stored in a particular order. Inside the HashSet, the elements are not stored in a particular order, whereas inside the TreeSet, the elements are stored in a sorted order. Okay, so whatever the elements that you add to the TreeSet, right, they will be automatically sorted. For example, if you store numerical elements into this TreeSet, they will be stored in lower number to the higher number. Okay, and if you try to store like alphabets kind of stuff into the TreeSet, they will be stored in ascending order. Like that, elements inside the TreeSet, okay, whatever the elements you add to the TreeSet, they will be sorted. Okay, automatically they will be sorted. Whereas in HashSet, there is no particular order, guys. Rather, instead, the elements added to this HashSet will be stored in a random order. There's no particular order. The order will not be preserved at the same time. It will be random order, guys. And coming to the performance of the HashSet, very fast. Okay, since there is no particular order, random order, and all, right, it's very fast. HashSet is very fast when you use HashSet for adding the elements or removing the elements from the existing list of elements and checking if an element exists or not. In this particular HashSet, whatever the element stored in that, a particular element is available or not. If you want to find that, do such searching operation, apart from adding, removing, if you are finding whether a particular element is there in the HashSet or not, the results will come in a faster way in HashSet when compared to when we compare this HashSet with TreeSet performance is slower in this kind of activities. Okay, HashSet is faster in this kind of activities, whereas the same activities like adding, removing, and searching for the element exists or not in the TreeSet is slower when compared to the HashSet. And here in the HashSet allows one null element. Only one null element will be allowed, whereas in the TreeSet, okay, does not allow null elements. Okay, you cannot add null elements here. Null elements are allowed, but only one, because duplicate elements are not allowed. So ultimately, null is also cannot be duplicated here. Only one null element, but here null elements will not be allowed. And where do we have to use the HashSet? Use when you don't care about the order of the elements and need fast operations. When you want to add the elements into the this particular class in a faster way, or remove the elements from the class in a faster way, and to search for the element from this in a faster way, then you go with the hash set. Okay. But if your requirement is to, okay, store the elements in a sorted order, okay, in a sorted order, then you have to go with TreeSet. Here order will not be preserved, but faster operations of adding, removing, and searching will be there in TreeSet. Okay, we generally use TreeSet when you want to, whatever the elements that are added to the TreeSet, if you want to have them in a sorted order automatically, then TreeSet. Okay, so let me practically demonstrate this, guys. Let me practically demonstrate this. Just give me a second. Let me practically demonstrate the differences between HashSet and TreeSet by writing the code. Here, I'll create a new package. Right click and create a new package. I'll just name this package as .5. Inside this package, I'm going to create a new class. I'll just name this class as I'll say HashSet. In real time, we use HashSet a lot, guys. Okay, in real time, we use a HashSet a lot. Okay, when you don't want duplicate elements to be stored, and then we generally go with the HashSet. Okay, HashSet demo. I'll give you HashSet demo with main method. I'll create. And inside the main method, I'm going to write some code, guys. Okay. Inside the main method, I'm going to write some code. That is, I need to create an object for the HashSet. HashSet is equal to new HashSet. HashSet is equal to new HashSet. And say Control Shift O. And here, less than greater than symbols I have to give. And inside the HashSet, I need to provide the type of objects I would like to store. That is integer, let's say. And let's add the elements into the HashSet. Let's add the elements into the HashSet. Let's say 9, HashSet dot add of 5, HashSet dot add of, let's say 7, HashSet dot add of, HashSet dot add of, let's say 1, HashSet dot add of 4, HashSet dot, let's say here 8, otherwise HashSet dot add of 2, HashSet dot add of, let's say 3, HashSet dot add of, I'll give 9 again. Okay, like that, any number of elements you can store. Okay, any number of elements you can store, and I'll try to add HashSet dot add of null, semicolon here. No error is coming. No error is coming. All these elements got add. Like now, let me print out the HashSet here. System.out.println. System.out.println HashSet. Okay, run this code. I'm printing the HashSet here. Run this code, guys, and observe that what is the output here. Observe what is the output. You see null 1, 2, 3, 5, 7, 9. Only 1 9 came. And here order is not preserved, guys, but it looks like order is there. But I'll try to add few more elements. I said that add of 127. Then here and there I'll add different elements. I said dot add of 99. Okay. Here I said dot add of let's say 30, 36. Okay, like the different elements I'm adding in between, and let me run this again. You see here the order is random. How can I say that it is random? You see 99 is coming somewhere here, 1, 2, 3, and lesser number is coming here. There's no particular order, guys. Okay, if you give more elements, you can find that out. Okay, the biggest number should be at the end, right? But 99 is coming in between. That proves that the order is not preserved and random order. Okay, there's no particular order in which the elements added to the HashSet will be stored in the HashSet. Okay, then performance will be very fast. You can do the adding, removing, and this theoretical part. Null values are allowed. Only one null element is allowed, because duplicate elements are not allowed. Automatically only one null element. And here duplicate elements, if you both same, this is not a difference. HashSet and TreeSet will not store the duplicate elements, so only 1 9 will be considered here. Only 1 9 will be considered here. And similarly, coming to the TreeSet, guys, coming to the use case, I told you already theoretically. TreeSet is something where here. So here, instead of the HashSet, I'll write the TreeSet, guys. Okay, instead of the HashSet, I'll write the TreeSet. I'll just copy paste this, copy this, and paste it here. Control C, Control V. Okay. Is there any name coming? Yeah, 2 is coming. Here I'll say TreeSet demo, I'll say, press OK. And I'll get the same code, but I'll modify that to TreeSet, guys. Instead of HashSet, I'll give TreeSet here. Instead of HashSet, I'll give TreeSet, Control Shift O, Control Shift O. Okay, then TreeSet, I'll give TSet. I'll just add the elements in the similar way to the HashSet. Okay, I'll add the elements similar to the HashSet. TreeSet. Like this, I'll give the elements, guys. Like this, I'll add the elements. After this, I'll print the TreeSet here and run this code. With the output, we can understand that the elements will be stored in ascending order. Okay, in case of numbers, elements will be, you see, null pointer exception is coming because you cannot add null. Whereas in case of HashSet, you can add null here. Only one null value will be allowed. But in TreeSet, null will not be allowed. I already mentioned here. Null is not allowed. Does not allow null elements. You are getting null kind of exception. You are getting like null pointer exception. You are getting. Let me. I commented the null element and just run the code here. The element should be printed in ascending order. You see, 1, 2, 3, 5. No matter how many elements are there, they are getting sorted out. Okay, the elements will be stored into the TreeSet in a sorted order. So like that, guys, these are the differences between HashSet and TreeSet. Hope you got the answer with this for this question with practical demonstration. So that's all for this session. Thank you. Bye bye.